So we have discussed the concept of dependency preserving in the last video. Now let's try to solve this particular question. Now this question is from previous year GATE CSE paper 2019. Okay. So let's try to solve this particular question based on the normalization and dependency preserving here. Let the state of functional dependencies, so f is given to us, hold a relation schema. We have a relation schema x. X is given to us, that is basically p, q, r, s. And we have a functional dependency applicable to that. QR determine yes, R determine P, and S determine Q here, right? Suppose X is decomposed into two schemas, Y and Z. So where Y is basically a PR and Z is basically QRS, right? So X is decomposed into Y and Z. Consider the two statements given below. First one is both Y and Z are in BCNF. Second one is the composition of X into Y and Z is dependency preserving and lossless. Okay, so we have to check for a BCNF condition and a lossless condition and a dependency preserving one. Okay, so the simplest one is to check for a lossless decomposition, right? So what does this mean, right? So how to check for lossless decomposition here? Lossless decomposition. So we have discussed few important conditions regarding the lossless decomposition. So first one is that R1 union R2 must be equals to R. So here we have Y union Z must be equals to X. So if you look at PR union QRS, so what we are going to get? PR union QRS, we are going to get what? PQRS. That is basically equivalent to equals to X here. It means what? Our first condition got satisfied. Second condition is what? R1 intersection R2 should not be empty set. So here if you look at Y intersection Z is what? We have something common, that is basically R. Now that common attribute or set of attribute must be a key of either Y or Z here. So how to check? So we need to take the closure of R here and see what we are going to get. So if I take the closure of R, what I'm going to get here? So R, so from R I can get P here, that is basically equals to what? Y here, right? So we got Y intersection Z is will give me Y. So all the conditions of lossless decomposition is satisfying here. It means what? My decomposition is lossless. This is fine. Now let's check for dependency preserving here, right? So here we have Y equals to PR and Z equals to QRS. Now, what are the function dependencies applicable to Y here? Let's say for example Fy, and let's say for example here we have YZ here. Now if you look at the original FDs, QR determine yes. So we have Z QRS. So you can add that FD into F2, that is basically QR determine S. So what about R determine P? So R and P is in the Y here. So we can write it down here. R determine P. Then we have S determine Q. Now, do we have S and Q together in decomposed relation? Yes, you can see Z. So I can write it down in S determine Q in FZ here, right? So that's it. We have three FDs in the original function dependency set, and all three FDs are getting preserved in Fy and Fz. So there is no FD remaining to check for dependency preserving. All FDs are getting preserved here. It means what? Decomposition of X into Y and Z is dependency preserving and lossless as well. Okay. So if you observe, all the FDs in the original F is getting preserved in the decomposed FDs here, like the Fy and Fz. So that's it. Our decomposition is dependency preserving, right? Now let's say for example, here we have P determine Q as well. We have one more FD, P determine Q. Now in that case, I cannot add in Y because Q is missing. I also cannot add in Z in Fz because P is missing. Now for such FDs only, which directly is not getting preserved in any one of the relation, for that only we need to check for dependency preserving here. Okay. So in that case, you have to follow that particular procedure what we have discussed. So first find out all the FDs applicable to Y and Z, that is Fy, Fz. Then consider F dash equals to Fy union Fz, and then take the closure of left hand side, that is basically P, based on the F dash here, and see whether we are getting Q in the closure or not. If we are getting Q in the closure of P here, while based on the F dash, then we can say it is a dependency preserving. This dependency is preserved. But in this case, all dependencies are getting preserved in the relation itself. So no need to consider these particular steps here. That's it. Okay. You have to consider these steps only when if any one of the FDs is not getting preserved directly in the decomposition. For that FD only we have to do this particular steps. Okay. I hope you understand this particular thing. So you can see statement 2 is correct, right? Now what about statement 1? It is both Y and Z are in BCNF here. Okay, let's try to solve this particular thing now. So BCNF condition. What's the condition for BCNF here? Left hand side of every functional dependency must be a key. Okay, this is what we are saying here, right? Now if we look at Y, that is basically a PR. So f of Y is basically what? R determine P here. If you look at Z here, that is basically QRS, and FD is what? FZ is basically a what? QR determine S and S determine Q here, right? So we need to find out all the applicable functional dependencies to Fy and Fz here, but we can go in with this FDs here. Now what we have discussed in the course, if any decomposed relation or any relation having just two attributes, any relation having just two attributes, that relation is in 4NF. It is in 4NF, it is in BCNF, it is in 3NF, it is in 2NF, it is in 1NF as well. So this relation will follow all the normal forms. No need to check for anything here. Okay. So we can say that Y is basically in BCNF because we just have two attribute. Also, if you look at the FD here, we just have R determine P. Can P determine R here? No. So we just have this FD1, FD only. And if you look at here, R is basically a key. R is basically what? It's a candidate key of Y. If I take the closure of I, that R, that will give me. If I take the closure of R, that will give me RP, that is basically Y. So R is a key, left hand side is a key. So you can see Y is in BCNF here. Now if you look at Z here, that is QRS. So FZ is what? QR determine S as determine Q. Now can any other FDs can be derived from this? No, that's it, right? Now what is the key of Z here? You first need to find out the key for this particular relation Z here. So we can follow our trick. Find out the attribute which are not present on the right hand side of any functional dependency. So if you observe here, S is present, Q is present. It means what? R is not present on the right hand side of any functional dependency. So first we have to check whether R is a key or not. If I take the closure of R based on FZ, what I am going to get? R only. So R is not a key. So I have to take a combination of R with remaining attribute. That is basically QR and QS here. So if I take a combination of QR, will I get all the attribute? Yes, because from QR I am going to get S. So that is basically equals to what? Z here. So QR is basically a key. What about QS here? If I take the closure of QS, so from QS can we get R? Let's see. So here from QS we can get what? SQ only, right? So we are not going to get R here. So it means what? QS is not a key. Only QR is basically a key of this particular relation Z. Now for BCNF, left hand side of every FD must be a key. Now if you look at here, Q determine S. So this is valid. This is valid in BCNF because left hand side is a key. What about this S determine Q? Is S is a key? No. So this will violate my BCNF condition here. It means what? Z is not in BCNF. Y is in BCNF, but Z is not in BCNF. So you can see option C is correct here. Only statement 2 is correct. Okay. I hope you understand this particular question. First, we have checked for dependency preserving and lossless, and then we have checked for BCNF here. Okay. You can follow anything. You can also check for a BCNF first and then check for statement 2. Okay. So the main thing is here you can see whenever all the FDs are getting preserved in decomposed relation, no need to follow that particular steps, right? Only in the case of any FD which is not getting preserved directly, for that FD only we have to check. Okay. So that is regarding dependency preserving here. This we already discussed in detail about lossless decomposition and normalization here. Okay. So I hope you understand this particular solution, what we have discussed in this particular video. That's it from my side. Thank you.